Hey everybody, so here's the plan. We're going to kind of walk through Pre-Calculus 1.5 and we're going to look at inverse relations and some other good examples. I'm making you video notes in case you just need some extra support as we go through things. So here's basically what happens. When I have an inverse relation, the way that I get that is that if I have an ordered pair, so if I have the ordered pair, some number A, some number B, I know that that's going to be in a relation if and only if the ordered pair BA is in the inverse relation. So let's figure out kind of what does that look like if I go into a graph. And so here it is. I'm going to graph y equals x squared. So if we were here together, I would be having you make an x squared with your body, and you'd be making a u. And so what we're going to do, we're going to go through and we're going to write the points of y equals x squared, and then I'm going to show you how we're going to get the inverse, and having the points is going to be hugely helpful. So let's start here. I know that I'm going to have 0, 0. So I'm going to graph that. I always start in the middle just because it's easiest for me. Now, if x was 1, then x squared, or y, would be 1. And similarly, if x was negative 1, then y would be 1 as well. Okay, so I'm going to graph those points, and you might be like, yep, I've done this before. Yes, you have. Well, if x was 2, then y would be 4. If x was negative 2, y would still be 4 because it's an even function. Let's see. Oh, that was not in the right place, so let's move that up a little bit because that's what you can do when you have a smartboard. And then maybe you also know that 3 and negative 3 would make 9. So I'm going to draw my nice little parabola there. That's all fine and good. So what happens when I make the inverse of a thing, I take and I just swap the points. So say, for example, I originally had right here 0, 0. Well, in my new graph on my inverse, 0, 0, if I swap the points, well, that's still 0, 0. Okay, so I'm going to graph this, and that'll all be fine and good. Now, right here, I'm going to go here. I'm going to take 1, 1, and I'm going to flip them. You may be thinking to yourself, still 1, 1. Yes, I know. However, when I look here, negative 1, 1, now I'm going to switch places with them because that's what an inverse does. I am now going to have 1, negative 1. So I'm going to graph those 2 points and see, oh, look, the inverse, something interesting is happening. Okay, so up here I had 2, 4. Now I'm going to have 4, 2. All right, so over 1, 2, 3, 4, 2. And then I know that the same is going to happen down here. So for negative 2. And therefore 9, 3, and 9, negative 3. I'm not going to put those on there, but hopefully you can see that that would be true because you know a lot about quadratics and have graphed them a whole lot before. So that's basically in a graph what's going to happen. Now, I personally generally have to plot some points and flop them. But really what an inverse is doing is taking this line up here. It's actually taking the line xy and reflecting something over the line xy. So I'm just going to grab this green one over here. Oh, maybe not. I'm going to grab this green over here and move it because, again, smartboard. Watch. So every point that's originally on the green line goes somewhere on the blue. So say, for example, I originally had 2, 4 was right here. Now it goes to 4, 2. And do you see how they are like equidistant from that line equals x equals y or y equals x? And so over here, this used to be 3, 9. Now it's 9, 3. They're equidistant from that line. So what happened was my y equals x squared, I reflected that over the line y equals x. Super important, that y equals x piece. And that's what gives me graphically the inverse. So let's move down and see what else we have down here. So now let's move the green back. Was the original a function? And the answer is, yup. was the new one, is that a function? And the answer is no. Why? Yeah, because it would fail the vertical line test in a whole bunch of places. So the answer is no to that. So could we have predicted this? The answer is yes, by this wonderful little test that we have. So if I go back up here, when I look, I could pass, that first one passes the vertical line test. So I'm just going to draw a vertical line. Ooh, that's pretty. If it passes the vertical line test, oh, I just moved the wrong thing, but that passes the vertical line test, yes? Yes. Now, but over this one doesn't pass the vertical line test. Well, could I have told that right away? And the answer is, Think about it. How could you have known? Well, you could have predicted that by the horizontal line test. So the horizontal line test, you could just take your original function, vertical line test it, yes or no, it's a function, and then horizontal line test it, and that tells you if the inverse is going to be a function, which is pretty slick. Okay, so let's just apply the horizontal line test to a couple to figure out how that would work. So because again I'm on a smartboard, I'm just going to draw a horizontal line test. So let's see the question, because it's always good to read the question. Which of the graphs 1 through 4 are graphs of relations that are functions? So the original is a function. All right. So let's see. This one. Does this one, the first one, number 1, does that pass the vertical line test? I'm almost positive you can see that the answer is yes. But just in case you don't see it, look at there. Here I've got a vertical line test. Does it pass? Yes, it does. Right here, there's an asymptote. But yep, everything passes. So that one's a function. How about this one? Nope, not a function because it fails all over the place. How about this one? Not a function because it fails. This one, yes, it's a function because there's asymptotes in there. Nothing is overlapping. So I didn't specifically write that down, but hopefully you can see that and write them in yourselves. Now, I'm going to check with my pink line. Are they relationships that have an inverse that are functions? Okay, well, let's look. So I can just take the original and let's horizontal line test it. Yep, that one right there, the inverse is going to be a function. How about this one? Ha! This one, the answer is yes. The inverse is a function, but the original was not. This one, nope, it's going to fail because it's like an oval. This one, nah, fails in a whole bunch of places. So the original was, and the new one wasn't. So, one quick thing that tells us, maybe you covered this in Algebra 2. Let's see if it's on the next slide. Yes, it is. Okay, so a function whose inverse is a function, so if the original is a function and the new one is a function, if they pass both the vertical and the horizontal line test, like graph 1, we'll go back to that in a second, that is called 1-to-1. This right here, 1-to-1, is outrageously important as you go in further in math. So in my algebra class that I'm taking right now, it's called Abstract Algebra. We're proving things are 1-to-1 all the time. Super important. So 1-to-1 means both the original is a function and the new, your inverse, is a function as well. So if I look back here at this one, number 1, that is 1-to-1 because the original was a function and the new one was a function. The other 3 fail in one of the places. Okay, so let's go here. So definition of an inverse function. Let's figure out what that is. So if f, and f is just the name we're going to call some function f, if f is a 1-to-1 function with domain D, so domain, which way does domain go? Yeah, that way. Domain is all your x's. And range, which way does that go? Up and down. Yep. Okay, so if f is a 1-to-1 function with domain D, range R, then the inverse function of f denoted. So what are we going to do? We're going to call that f inverse. So that looks like f to the -1 power, but really the way we say that, the vocabulary, is f inverse. So denoted f inverse is the function with domain R and range D defined by this. So here's how we write it. If and only if f of a equals b. So do you see what happened originally? So in the original function, that's right here, we plugged in a and we got out b. So the inverse says we plug back in the outcome and we get what we originally put in. Do you see? So they just swapped. Now, here's the cool thing. If the original function, this one had domain D and range R, well then, because everything switches, your domain for this one is now R because they swapped places. And your range is what the domain of the other one was. So everything swaps back and forth. So there we go with that. We're just going to stop right there. So that is video 1. And then I'll go a little bit further. So we're not done yet. That's just part 1 to kind of show you what an inverse is, how we find it, what it does.